In this video, we are going to be finding the current flowing through this 2 ohm resistor using the superposition theorem. But first, what is the superposition theorem? The superposition principle states that the voltage across or current through an element in a linear circuit is the algebraic sum of the voltages across or currents through that element due to each source acting alone. Now, what the superposition principle is basically trying to tell us is that in a case where you have more than one power source in the circuit, and you want to find the current or voltage across a particular element in the circuit, you can turn off other power sources while leaving only one on, analyze the circuit, then do the same thing for other power sources, independent power sources to be specific. Then at the end of the day, you can sum up the voltages or currents through the elements you're trying to work with, and the algebraic sum would be the actual sum of would be the actual value of the current of voltage across the element if they were acting together. I'm going to go ahead and demonstrate that in this circuit. So we want to find the voltage across this 2 ohm resistor. So what we do is that we turn off the voltage source, this 10 volt source. We turn it off first, and when we turn it off, if in the case where we turn off a voltage source, we short circuit the path. If you turn off a current source, you open circuit the path. Now, in this case, we are turning off the voltage source, and our circuit will look something like this. Now, we want to find the voltage across the 2 ohm resistor in this circuit. And in order to do that, we would use a current divider. If we use a current divider, the current flowing through this arm, would be let's say this is R1, and the sum of these two resistors, the equivalent of these two resistors, which is R2. So that means that 3 plus 2 equals R2. So the current flowing in this branch would be I1, and that would be R1, that is the current flowing in the opposite branch, over R1 plus R2 multiplied by the current I, which is the 4 amperes. So the current flowing in this branch would then be I1 equals that is 2 plus 3, that is 5, into 5 plus 5, 10, multiplied by 4, and that would give us 2 amperes. Okay, we know that 2 amperes of current is flowing in this branch. 2 amperes. So we know that 2 amperes of current is flowing in this branch. So what will be the voltage across the 2 ohm resistor? And the voltage across the 2 ohm resistor would be V is equals to IR, and that would be 2 times 2, and that would be 4 volts. 4 volts in this direction, because the voltage drop would oppose the current, the direction of the power flow. Proceed to the next power source, which is the voltage source. In this case, we are turning off the current source. By turning off the current source, we open circuit it. We open circuit the circuit. Then this is quite easy. What we just do is we use a current divider, a voltage divider formula to find the voltage across the 2 ohm, the voltage drop across the 2 ohm resistor. And the voltage divider is, if you call this R1, I'll make this R2, I'll make this R3. Using the voltage divider formula, the voltage across this resistor, let's make it V3, would be equals to R3 divided by the sum of all the resistances, R1 plus R2 plus R3. And in this case, V3 would be equals to R3, that is 2, divided by 2 plus 3 plus 5. V3 should be equals to 2 divided by 10 multiplied by the voltage source. Sorry, this should be multiplied by V, 10. And then we would have 2 volts. So due to this voltage source, we'd have 2 volts. We'd have 2 volts plus minus in this direction. So then we can come back and we can sum it up. We can sum up the voltages, and we will have 2 and 4. We can then sum them up, and the voltage across this resistor would be 2 plus 4, which would be equals to 6 volts. And that would be all for today on superposition theorem. Thank you for watching the video. See you next time. Bye.